We're moving into interpreting the graphs of linear models in their context. We are looking specifically now at the complex familiar question in exercise 4A part 2, question 3. So the graph opposite can be used to convert temperatures in degrees Celsius to temperatures in degrees Fahrenheit. It's asking us to find the equation of the line in terms of F and C. Okay, so firstly we have to decide what is what, F and C. So I've got a copy of the graph here, and it's got C on the x-axis and F on the y-axis. So in true form, I'm firstly going to state the general equation, y equals mx plus c. Okay. So therefore, having a look here, the y-axis is f, so I can state that now as f equals mc, and that's capital C plus little c. Okay, so now we have to find the gradient and the constant. Alright, so we can actually read the constant because we know that that is the y-intercept. And lucky for us, they've given us the coordinate to the point where it crosses. So that is 32. So we can state that. We can state that little c equals 32. And we can work out the gradient m by using our rise over run. And because we've got 2 points, we're going to have to go that as y2 take y1 over x2 take x1. And let's call this point 2 and this point 1. So let's substitute our values. y2 is 104, take y1, which is 32, and x2 is 40, take away 0, which is our x1 value there. So let's just make sure we get the values right. 104 take away 32, that equals 72. 40 take away 0 equals 40. Let's then turn that into a decimal, 1.8. So the gradient equals 1.8. So we can now easily write the equation of f in terms of f and c. F is going to equal 1.8c plus 32. So that is the answer to part A. So part B is asking us to use the equation to predict the temperatures in degrees Fahrenheit when the temperatures in degrees Celsius are, and it's giving us different values. So B1, we've got C equals 50, so F is going to equal 1.8 times 50 plus 32, which equals, that into the calculator, 122 degrees Fahrenheit when it is 50 degrees Celsius. Okay, so for part 2, same deal. This time C equals 150 degrees Celsius. So Fahrenheit will equal 1.8 times 150 plus 32. We are just substituting into there, popping that into the calculator, 1.8 by 150 plus 32, and it equals 238 degrees Fahrenheit. For number 3, same deal, except this time, making sure you're putting your units in when you're doing this. We've got negative 40 degrees Celsius, so we're putting a negative number in, so F equals, move it up here so you can see it. So F equals 1.8 times negative 40 plus 32. And we'll just get an answer to that one. 1.8 times negative 40 plus 32 equals negative 40 degrees Fahrenheit. Okay, so we've done parts A and we've done part B. I'm just going to move the graph out of the way, give me some more whiteboard space. Okay, so part C is asking us to complete the following sentence by filling in the box. When the temperature in Celsius increases by 1 degree, the temperature in Fahrenheit increases by how many degrees? Well, let's have a look here. So part C, we are actually looking at the rate of increase. And we can see that for every increase in 1 degree in Celsius, the rate of change is 1.8. So therefore, the rate equals 1.8, and you would put 1.8 in the box. And that's the end of that question.
Oh.